All right, so now that we have our table, I'm going to graph it, and I see that my y-intercept should be -3. When I look at the first point I'm graphing, I have 0, -3, which is where that ends up crossing my y-axis. 1, -2, and 2, -1. So when I graph my equation, if I graphed it correctly, we would see that every point is shifted 1, 2, 3 units to the right. So that means the basic result of this is that every point is moved to the right 3 units. And that's because I subtracted 3 from x inside my parentheses. All right, let's look at another example. Here I have the original function f of x equals 2x, but now I'm going to replace that x in the original function with x minus 3 because it's inside the parentheses. So my new function is going to be the 2 and then times x minus 3 because x minus 3 replaces x. So I get 2x minus 6. So my original equation, or my new equation, is going to be 2x minus 6. Graph, or build my table, x and g of x. I'm going to do 0, 1, and 2. Substitute 0 into my original equation, I get -6. Substitute 1, I get -4. Substitute 2, I get -2. So when I graph that, 0, -6 is there, 1, -4 here, and 2, -2 sits there. So my graph is going to be right there, and I can see that based on my y-intercept there, everything shifted over 1, 2, 3 to the right. So in my original g of x, I was taking 3 away from x, so that's consistent. It shifts every point to the right 3. And we'll get to where we'll be able to look at this, recognize the value, what's happening, what's the effect, and then we won't have to do all the graphing on it. But I will tell you that using your graphing is a great way to double check and make sure that you're looking at your items correctly. Number 6, my original function is -2x minus 4. Again, I'm going to substitute x minus 2 in for x to get my new function. So I'm going to have -2 x minus 2 minus 4. So I have -2x plus 4 minus 4. And here, that end result of that is 0, so my function is now going to be -2x. So, based on what we have seen so far, if the pattern holds true, then what's going to happen is, because I came into my original function and I took 2 away, every point should shift 2 units to the right. But let's graph it to make sure we understand what's happening. So when I substitute 0 into my original equation, I'm going to get 0. Substitute 1 in, -2 times 1 is going to give me -2, and 2 times -2 will give me -4. So 0, 0 is basically the origin. 1, -2, I go over to the right 1 and down 2, and then 2, -4 to the right 2, and down -4, down 4. Apologize for my lines. But you can see right here on the x-axis, it shifted it over to the right 2, which is consistent with what we have been learning. So this is going to be shift to the right 2 units. Number 7, come up with our new equation. So I'm going to take x plus 6 and substitute it in for x. So I'm going to have 1/2 x plus 6. X plus 6 minus 1. Again, if I know that subtracting 2 inside the parentheses shifts it to the right 2, think about where it should move when I'm adding 6 to the inside. So my new equation is going to be 1/2 x, half of 6 is 3, 3 minus 1 is 2. So my equation is 1/2 x plus 2. And then I could go in and graph just to verify and see. I end up substituting 0 in, I get 2, 0, 2, and then I substitute 1 in, I get 1/2 plus 2, and that's going to be 2.5. 2 times 1/2 is 1 plus 2 is 3. So let's graph this. 0, 2, so 0 up 2. 1, 2.5. And then 2, 3, right there. Now when I look at this, I can see that when I look at my x-intercept, from the original line to the other line, everything shifted 1, 2, 3, 4, 5, 6 units. Everything shifted, every point shifted to the left 6, which is consistent with what we had seen. So now I move every point left 6 units. So if I'm adding inside the parentheses or subtracting, I have to know whether it's shifting it to the left or the right and understand that it is affecting the x-intercept. All right, so what I want you to do on the next ones is I want you to practice, and then we will check through it in class.